Yes, welcome to the webinar, everyone. It's World Water Day today. So, why a day for water? It was conceptualized by United Nations in the year 1993. Water has been highly neglected despite of its high value, and it was at the peak of industrial revolution that we had started facing dire need of water. And that's when United Nations announced a day for water to generate awareness and to protect the resource which is available only to us. Every year they have a different theme addressing different issues. This year's theme is groundwater, which is also a part of sustainable development goals and goal number 6 within that. Today's agenda, I've broken it down into smaller chapters. First being understanding India's water ecosystem. Second, what role groundwater plays in the water ecosystem. Third, what are the challenges faced in the groundwater arena? Possibilities and successes to overcome such challenges. Model case study of how solutions can be replicated, and the message of making groundwater, which is invisible, visible, and to conclude with knowledge dissemination, which is creating awareness through this. So today I'm going to cover groundwater from India's perspective and the challenges associated with it. Let's go ahead. So India is a prosperous nation, and being water rich is one of the indicators. India's water ecosystem comprises of three key sources. First being rivers. I'll help you explain with the help with this map. So rivers are the major source of water in India, and they are the lifeline. The major river basins are broken down into four different types and then followed by tributaries. The first and the biggest one being the Indus Basin, which originates from Tibet. It flows across Kashmir through Punjab, then Pakistan, and that ends into the Arabian Sea. The prominent rivers are Jhelum, Chenab, Ravi, Bias. Second and most prominent one is Ganga Brahmaputra Basin. This spans the longest in the country. It again originates in Tibet and northeast India, that is Uttarkashi. And the prominent rivers in that basin are Yamuna, Sone. So Yamuna being one of the most prominent rivers. Third is Peninsular Basin. Peninsular Basin is in the central part of India. And last is Coastal Basin. These are the rivers flowing along the coast. So there's a very high possibility that you can relate to at least one of these river basins. Second, now civilizations were set up and raised by the rivers. Hence, rivers, river banks are still considered sacred, even till date. We understood back then when the civilization started that we need to move towards the land, away from the rivers. But then, how can we move water from a river? So that's when infrastructure was invented to collect and distribute water. The circles marked on the map denote reservoirs, which has dams, lakes, artificial reservoirs, catchments, etc. So these are the locations where the water of the river is uh, held, exploited, harnessed. It is distributed to the inland areas. Third, and the most crucial one of all these sources is groundwater. Now, let me give you a quick fact. Cartography, it's a skill of making maps. So, cartographers have honed the skill of making maps for centuries. Yet, there wasn't a map for groundwater that makes groundwater invisible, right? It can't be seen or noticed. It is a very recent technological development with effort of experts across the globe. Now we have an approximate map of groundwater. Let's see how it looks. So this is how it looks. When the map was starting to take shape, we learned that it was extremely difficult to locate groundwater. This is the map of today's groundwater situation in India. On the right, you would see a scale starting from red, which is stressed, and blue being the safest. India is in dominantly in red and yellow zones. So this means that once we prepared the map, we understood that our groundwater situation is dire. And if you notice on the top left, Rajasthan, it being a desert, yes, it is water stressed. The groundwater levels are not that prominent there. But if you look at Punjab, which is called as the granary of the world, or it produces the largest amount of crop produce in the country, that has exploited the maximum amount of groundwater. Now let's dive deeper to understand groundwater. So what exactly is groundwater? Groundwater is nothing but rainwater. So how does it get there? So groundwater is subsurface rainwater held in the geological formations. It's a bit technical, but whenever it rains, the water on the terrain, whenever it is incident on the ground surface, the water tends to flow. It finds areas where it can run off, considering the terrain. There are areas where the ground can hold water. That is the third picture. This is where the water starts to percolate. So part of the water is held in the soil as moisture. Majority of it evaporates. Then whatever is left, that starts to seep into the ground through percolation. That is held in shallow aquifers. Now, aquifer is a technical term. The simple meaning to it is it holds any area beneath the earth which can hold water, which has the potential to hold water. So there are shallow aquifers at a shallow depth of say 5 meters, 10 meters. This is where we get water from dug wells or kua as we call it. And then next comes that is deeper aquifers. So deeper aquifers, as the name suggests, they go deep below the ground. It could be 100 meters, 200 meters, 500 meters below the ground, and this is where water is retained for centuries or even millennia. So basically groundwater is nothing but subsurface rainwater. Now, where do we find groundwater, or how do we locate it? As you see, it's a very recent development that we can at least identify where the water table is high, or where groundwater is available, or where it is not. Groundwater behaves very differently. Unlike a much more predictable source like river or lakes, it follows that topography, it follows the terrain, whereas groundwater does not follow the surface terrain. There are different kind of fractures beneath the earth where the water tends to fill in the space, and it moves constantly. So it is just like a river, but it is underground, which we cannot see, which we cannot track its location, its movement. So it is all the more difficult when we have to extract groundwater. But there is a good side to it. Since groundwater is like a reservoir which is accumulated over centuries, we have managed to strike groundwater at an astonishing strike rate. So 9 out of 10 locations where we dig, we strike water. So the oldest documented method of harnessing groundwater is step wells. The first photo on the left corner is a step well in Rajasthan. So that's the method where we used to tap the groundwater, and this groundwater would suffice the water requirements in summers, especially whenever it doesn't rain. Second, as the technology moved ahead, again, the second picture on the top right is a dug well. So it's a smaller version of a step well. Again, it was done manually. Third, on the left bottom corner, it's again a dug well, but now with more technology, dug wells were started being made with mechanized excavation or blasting. So if you ask me how many number of step wells are there in the country, maybe there are over 100 which are known to us, which we have discovered. How many dug wells are there? Maybe a state would easily exceed 500,000. The last and the most crucial one of all these is borewell, the one on the right corner, which we see in every farm, in every probable bungalow or society or an industry where the construction is happening. So borewell is the latest technology which can go as deep as it can drill holes as deep as 2000 feet from the ground. It is size of a skyscraper below the ground. To give you a very shocking fact, a city like Pune alone has over 100,000 borewells within the city from which we are extracting, I mean, the city is extracting water. And there are a minimum of 5 known borewells that are being drilled each day. So this is where the context comes in. What is groundwater, where it is found, and how we are extracting groundwater. Having said that, let's understand what our relationship with groundwater is. It dates back to centuries. Our civilizations, they started around rivers. Indus River civilization being the oldest, it was the name comes from the river Indus. The next stage was we discovered groundwater, which was good in a way, but we started moving away from the river banks. This is where villages, communities started setting up. This, coupled with the modern infrastructure, led to development. How did that happen? When we started moving away from the rivers, we started farming throughout the year. Earlier, farming was dependent only on monsoon. We had monsoon crops only. Now we have crops in winters, in summers. How does that happen? It doesn't rain then. It is on groundwater. Second stage was urbanization. Like how the settlements or civilizations were around the rivers, now villages, communities, cities started to take shape. Now we have cities on hilltops also. Third, when the cities started developing, now we come to today's day of industrialization. So these are the three stages which have happened after the discovery of groundwater. Now, for any of these developments to happen, we need three things. First is infrastructure, which is laid or manufactured. Second is power, which is generated. And third is water, which can neither be generated nor manufactured. We can sustain without roads, electricity, infrastructure for a few days or weeks or even a matter of a month, but never without water. That's the reason why we have to understand this resource better. Now, with this context, what are the challenges? Let me walk you through some statistics. This is a rough distribution of fresh water in our country. So, of the total fresh water available that we have, uh, various studies have worked out on different models. These figures vary back and forth. But just to give you a rough idea, I have the stats are absolute figures for easier understanding. So, out of the total fresh water that we have available, 70% is blocked in snow caps, and 30% is actually available to us in usable form. So, of that 30%, 29% is groundwater, and only 1% is surface water. And surface water, by that, what we saw earlier, rivers, lakes, dams, they comprise only 1% of our entire water ecosystem. This is where groundwater plays a very crucial role. Now let's understand the usage of water in the country. So India was primarily an agrarian economy, but post 1950s till date, now we are an agro-industrial economy, and both these sectors are heavily dependent on water. If you notice, 80% of the fresh water that is consumed in India is only for agriculture. So the agricultural output comes from water alone. Second is industry, which is fairly lesser, 10% of the whole distribution, and 10% is domestic usage. That is what we use for our day-to-day use, sanitation, cleaning. To give you another number, 80% of country's agricultural output is entirely dependent on groundwater. Only 20% is reaped out of monsoon or out of natural rains. And next, 60% of industrial output is sustained on groundwater. So it would be fair to say that India's economic dependence on groundwater is at a staggering 70%. Now remember guys, as I started with, it is not visible. Yet we are so heavily dependent on it. Imagine not having groundwater, it would literally paralyze our economy. So, what are the challenges that we are facing in the current scenario? There have been a lot of news that India is being pumped dry, we will soon expect day zero. Well, rightly so, since groundwater is not visible, out of sight is out of mind. We have been extracting it beyond proportions. The rate of extraction of groundwater is probably 10x, 20x, multiple times the rate of natural replenishment. The natural replenishment of groundwater happens through natural percolation, which again takes decades. Due to this, groundwater, a very finite freshwater source, is under immense stress. Now, having given you the context of what is groundwater, how do we find it, what are the challenges, now I'll walk you through some possibilities and successes. It's a very small example. Now, with the context of what role groundwater plays in the economy and stress it is under, let's look at the first case. This is a case of a school where we worked in 2014. So it was a Jilla Parishad government school in a remote area. The problem there was quite unique. The attendance of the girl students in the school was perpetually low. And it was surprising that the school approached us saying, our attendance is low. I mean, girls' attendance is low. Could you help us with that? When we analyzed the situation there, the root cause there was young girls, school going girls, had to walk for kilometers to fetch water through the day. So they ended up getting so tired they could not attend the school. One. Secondly, the school being in a remote area, they did not have a water resource for sanitation within the school. So it was all the more reason for the girls to not show up to the school. What we did was they had a dried up borewell within the premise, and we used that and we revived that. To our surprise, after 2 to 3 years, the same borewell, if you notice the picture in the right corner, this is actual footage of the school where the groundwater, the borewell was revived with rainwater. And after 3 years, the school gave us a feedback saying now they have enough water for sanitation throughout the year and the attendance has gone up. So, in this context, water is education. It's a very small case study, but water, as I said, does not carry a price tag to it, it has a value. Next is a industrial example. So it was a manufacturing industry. Its processes were running smooth until there was a shutdown in the industrial corporation that day. The manufacturing process needed steam for their product. Since there was no electricity, they could not get water. Since there was no water, there was no steam, and there was production loss. Likewise, there was man-hour loss. So there in that case, what we did was whatever water was falling on the property, we created a water body within the premise of this scale, which could hold 40 lakh liters of water. This gave them a buffer of 7 days of production. Now, how do we ensure that water stays within such a premise? If you notice, there is no concreting or there is no chemical treatment beneath the surface, but it started to hold water. Earlier, when we started it, it was this, and after 3 years, the groundwater, which was unusable water, contaminated water, which did not exist earlier within the premise, is now as clean as this. This is enough for 60 days of production. Now they are so possessive of this water, they even got it covered to control the evaporation losses. Just in case there are percolation losses, they wanted to arrest the evaporation losses also. And the scale of it is it can easily fit an international airliner. Now, the point of this case study is we had drilled a monitoring well of 100 meters deep within the premise. So the water body cannot hold water until the groundwater is saturated. So once the ground starts accepting water, once rainwater is replenished into the ground, which in turn turns into groundwater, the ground starts getting saturated and that's where the levels start rising in. So water body could only hold the water in itself after it was saturated, the ground was recharged, and the level started augmenting. This can be measured and the results are evident here. These are the data points gathered through groundwater monitoring and it corroborates with the rise in water table. So making water available for this particular industry, it means no production loss or no man-hour losses. In this context, water for this industry means productivity. And the last case here, it's a manufacturing company where hundreds of people are working. The revenue of this company is in multiple of 100 crores, but they were entirely dependent on groundwater for their process. There was no piped water supply here. Notice all the area in the surrounding is arid. It's a drought prone zone. What we did was we understood their processes. We apply the way we apply this logic is there's a term in medical field called as biomimicry. We try to replicate solutions that are there in the nature for its own recovery, and we try to replicate those for our practical day-to-day problems. This is where we identified the one of the areas. We understood the geology. We thought that this could hold water. Then we started clearing the area with dredging, de-wading. We made recharge structures of 100 meters deep of variable depths within the premise. First monsoon, the ground was just accepting water through these recharge wells or through this open area, since it had dried up quite a bit. In the second monsoon, the ground started to get saturated, and that's when the water level started rising in. This is in monsoons. After 4 years, the groundwater table there rose almost fivefold. And now there is a beautiful water body which is holding water naturally without any concreting chemical process. And the biggest testimony is that migratory birds have started coming here. So, more the water, more is the revenue for the industry. Groundwater in this facility promises business continuity. And in this context, water is revenue. So, stopping at these three case studies, there are, in my experience of over 500 projects and 10 years, I've learned what water is for real. What that water doesn't have a price; it has a value associated with it. Water is education, water is industry, health, economy, sustenance, and many more things. I'm thankful to these four front runners for taking up water initiatives. They've trusted us and helped us demonstrate such results. So to sum it up, as the context changes, the meaning and value of water changes for the beneficiary. So this is a good place to ask yourself, what does water mean to you? Water indeed is freedom for our nation. Water is security to India. And having seen the challenges, possibilities, success, there is a brighter side to this situation. Groundwater indeed is a boon. It's a finite yet abundant source of water. It is the purest form of water of the multiple sources. It remains fresh for centuries. It is insulated from climatic variations since it is beneath the surface. And remember, even if the world ceases to exist, groundwater will always exist. And to give you a funny example here, this is one of the reasons that we are exploring space to look for water on other planets. And the fact is that mankind is spending billions of dollars to check if we can find traces of water, groundwater, beneath Mars and moon surfaces. We have it on Earth. All we need to do is secure what we have. So, over 80% of our projects that we have done in different terrains are directly related to groundwater. I'll narrow it down to a smaller scale to illustrate. Narrowing down to Pune. So I'm here in Pune where we have multiple cases in this belt where areas away from the central city or the central urban area, those are the ones which are highly dependent on groundwater and are likely to be water stressed. If groundwater can be augmented, preserved, revived in a model like this, it can definitely be scaled up to a national level. So the map which we saw earlier of groundwater, where we are in red or yellow, that can definitely turn to blue entirely. So one more fact, which is a disturbing one. So we have a threat from China and Pakistan. If in any way they are able to curb or block the flow of rivers originating from Tibet, they will have India paralyzed without them having to even fire a single bullet at us. It is groundwater which will protect India in these kind of threats. So together we can make a rich groundwater map of India. Thankfully now, with the changing environments, central government, industries, policymakers, they've come together to drive this change. Any project associated with water or groundwater is linked to one of these ESG, any of these ESG, Sustainable Development Goals, water positive or neutral initiatives, central groundwater compliance, and so on. So to conclude, making invisible visible, making groundwater visible, these are some of the indicators that groundwater levels have to increase from a certain level, bringing back life to dried up aquifers, reviving dead water bodies, or remediating ones which needs that kind of remediation. Groundwater means moisture retention in the ground, sustained vegetation, forest and arid lands, and in turn biocity. That is an indicator that yes, there is groundwater here. So there is a 6 point plan on the lines of awareness. First is observe. Observe areas where water can be stopped, where water can be conserved, or where groundwater could be recharged. Second is measure wherever possible and economical. Groundwater levels can be measured, can be monitored. Third is monitoring post measuring. And point number 4, 5, 6 are the crucial action steps which we need to take to recharge, replenish, or revive dried up groundwater. So to summarize the whole uh, session today, first we saw India's water ecosystem. Second, what groundwater role plays in the whole system and what is our relationship with it. Third, the challenges in India's groundwater consumption and the stress it is going through. Fourth, possibilities and successes, which in turn led to us knowing that water is security, water means security to our nation, model case of Pune, and other compliances, and making it visible. To conclude, this session is completely informative. So, knowledge dissemination is something which is a part of sustainable development goals. All that I've shared today comes from facing many failures, success, and continuous learning. I'm passionate in sharing my experience and learnings. I started with such awareness sessions at Ganesh Pandals in 2013. Then it moved to Senior Citizens Club. Those grandparents referred us to their grandchildren's school. Then it picked up traction. Premier institutions started calling us. So the point that I'm trying to make here is awareness is something which is very crucial. And awareness brings clarity of thoughts. And that in turn drives action. And with the support of all these clients, we have been able to expand the impact across various regions. So on a closing note, on today's occasion of World Water Day, I like to share my vision with you that it is to make India water secure.